So today what we're going to do is we're going to look at graphing the derivative of f, okay, and what that graph would look like. So it's really quite easy when you have line segments like this because this is a line right here, okay, and whatever the slope is, that's what the derivative is for all of these values in here. So if you look at this, the slope of this line right here is up to and over 1. So this piece right here, my delta y over delta x is equal to 2, which means my slope's going to be 2 the entire time from 0 to 1. So that means we're going to graph right here from 0 to 1. The slope is always constant. It's always the same. It's always 2. Now, I'm going to talk about this right now in that this left endpoint we're going to include, but this one we're not, okay? And here's why. The derivative changes instantaneously right here at this spot right here. The left, remember it's a limit, so as we approach this value from the left, it's this, but as we approach it from the right, it's this one. So those are two different values. So that's going to cause it to jump, okay? So this next one, we have a slope, okay, and we're going to go up from 2 to 4, so that's an increase of 2. So right here, my delta y over delta x is equal to 2 over, and we go from 1 to 5, so that's a difference of 4. So then that's 1/2. And you can, make sure you get the signs right too. This is going up, so yeah, my slope should be positive. So this is 1/2, but it's 1/2 between 1 and 5. So it's 1/2 between 1 and 5, and it's always going to be that constant. So it's going to be somewhere right about in here. So 1 to 5. Now, again, on the left side, it's this slope, but on the right side, it'd be this slope as we bring another point into this point. So that's why we can't find the derivative right here. And I'm going to talk more about this over the next few days, okay? So don't worry about it if you don't quite get it right now. It's just this, you can't have a slope be both these values at the same time at that x equals 1. And you would need it to be for this to work. Okay, so then we're going to have another one right here. And then from 5 to 8, my slope, my change in y over change in x is 0 because there's no change. So delta y over delta x is equal to 0. And that's going to happen from 5 to 8. So from 5 to 8, I'm going to lay my ruler right on top of the x-axis and go from 0 to 8. So right here, right in here. And once again, we wouldn't be calculating it. We can't have a slope right there because from the right side, it's 0. But from the left side, as we approach this 1x value, it's going to be 1/2, right? So those are two different values. And that's why there's this jump discontinuity right there. Okay. And so this is also going to be open right there at 8. And from 8 to 10, we're going down 4 and over 2, right? So for this one, my change in y over my change in x, I'm going to go down 4, so that'd be -4 over +2, which gives you a slope of -2. So from 8 to 10, my slope is going to be -2, so I'm going to line up. All right, and we're going to be right there. This one is going to be open because right there it changes the derivative or the slope changes instantaneously right there from being 0 to being -2. So that's why we can't have a derivative right there. And then right here at 10, there's only one side, right? So if there's only one side, that means we can include it. And that would be a closed dot. So all of these are open dots. The right endpoint and this left endpoint are going to be closed dots. Okay, so that's graphing f if you have the graph of f and it's connected line segments basically, okay? What if you have a curve? Okay, so let's talk about that next. So I want to make this clear even before we start. The graph of the function is shown, so that's this one, right? This is y equals f of x. Okay, we are not going to graph a dead-on accurate derivative. It's going to be the shape of it that we're going to get, okay? So some things to always look for, these are some things that I say for students to look for, is look for where you have horizontal tangents, okay? So right here at the bottom, okay, and remember, okay, if we have tangent slopes, this is coming in, right? All these x values, and it's curving, right? And the tangent would be horizontal right there, okay? So that means right here, we know we have a horizontal tangent, okay? So I'm gonna just go ahead and draw my line right there. That represents a horizontal tangent right there. So let me write horizontal tangent, which means the tangent slope is 0 there. Okay, if the tangent slope is 0 there, then that means the derivative at that x value is also 0. So this is at x equals 0. So at x equals 0, the slope is 0, which means we can put that point right over here. Okay, so basically what it is, it's going to be the value of all of these slopes, okay? All right, so if you look, tangent lines on this side of that horizontal tangent, all of them are going down, right? They're decreasing, they're going down. All the tangent lines are going down and down, right? So on this side, all of the tangent lines, okay, or tangent slopes are all negative. So all the tangent slopes on this side of the horizontal tangent, on the left-hand side, are going to be negative, which means my graph has to be negative in that region, right? So up to 0 on this side, my graph is going to have to be below the x-axis. Again, why? Because all these tangent slopes are going down, right? And so that means you're going to have a slope that's negative, and this is where you're going to get the slopes that are negative. All right, over here, this side of it, okay, our tangent slopes are positive. Okay, so if you pick a point right here and you drew a tangent line, right, it'd be going up, it'd be increasing. Every single tangent line would be increasing. Okay, so that means for this part of the graph, it's going to be up here. Well, if this part's below and this part's above, it's just going to go straight through. Okay, so it's just got to be something. It's not going to be accurate, but it has to. This side, I'd be looking for it. All I'd really be looking for is for this part to be below the x-axis and this part to be above. You really don't know enough to know that that is a line. Okay, all I would be looking for is it's going through there. This part of the graph is below and this part is above. That's what I would grade you for. Okay, so this represents kind of the general shape of y equals f prime of x. That's the graph of this derivative. Now we did it yesterday, okay, and you may realize, hey, every time I take the derivative of a quadratic, and this is a quadratic right here, it's parabola, you always get a line, right? You're always going to get a line. There might be different lines, but you're always going to get a diagonal line like this, okay? So that's one of the reasons I knew this was going to be a line, not just some curve that happens to be below here and above here, okay? And as you get more into calculus, you'll go, oh, okay, I get it, all right? It's just going to take some time. All right, so for this one right here, this is the graph of y equals f of x. And we're going to graph y equals f prime of x. Okay, so one thing I want you to look for is these horizontal tangents. Okay, so right here, there appears to be a horizontal tangent. Right here, there appears to be a horizontal tangent. And then again, right about here. Okay, this one is not right on -5. It's just a little bit to the left. Okay, so these kind of look like they're the same horizontally same spot. So we have a horizontal tangent right there and a horizontal tangent right here. And then we have another one right up here. Okay. Now, what does that mean on the graph of the derivative? That's where it's going to cross the x-axis. So right here, just a little bit to the left of -5, we are going to have a point right here. Okay, and then right here at x equals 0, it's going to cross the x-axis. And then right here, just a little bit to the right of 5, it's going to cross the x-axis. Because the slopes are all 0 there, right? Tangent slope. Is 0. Okay, now let's look at everything in between. Okay, so for everything in between, all right, all of these slopes right in here are all the tangent slopes in here are going to be negative. All of these are going to be positive. All of these tangent slopes are negative, and all of these tangent slopes are going to be positive. So what that means over here is since these are all negative right here, okay, that means the graph of f prime is going to have to be below the x-axis. So this tangent slope is negative. I'm going to just write a little negative sign. Okay, that means f prime is below x-axis. Because here's where this is, okay, you put an x value into this and it tells you the slope, right? And so all of these slopes have to come out to be negative. So we're coming through and we're going to do something like this. Now, really, we don't know the shape of it other than, you know, this part of it has to be below. And that's all I'd be grading you on, okay? So all these tangent slope is positive. So it's going to be f prime. F prime is above x-axis. So from this x value to this x value, my graph has to be below, but I got to get back to this point. So what's going to have to happen is there's going to have to be a turnaround point somewhere where it comes back down. So where you draw that turnaround point, you don't have to concern yourself with that right now, okay? That's actually, we need calculus to do that, and that's later on, okay? All right, for the next one, we know that these, I'm not going to write this anymore, okay? We know that all these tangent slopes, we should recognize these are all going to be negative, which means from this x value to this x value, my graph has to be below the x-axis, so it has to be somewhere here. But I got to get to this point. So there, again, there's got to be a turnaround point somewhere in here. And where you put it exactly doesn't matter. Got a little mosquito buzzing me right now on my hand. Okay, so it's going to come up like this. Okay, and then from here, from this x value just a little bit to the right of 5, all the tangent slopes are positive, which means now my graph of f prime would have to be above the x-axis. And so this part would have to be above like this. So it would look something like this. Killed the rat. No, maybe I didn't kill the rascal. All right, enough of that. Okay, let's go to the next problem. I meant to say something earlier, but usually I give you guys grids. I give you the graph paper to graph these, but I can't give you the graph paper. So if you just do, like, to graph this one, what you need to do is just graph on your graph paper that in the notebook that we gave you guys, okay? Just make a graph from -10 to 10 and -10 to 10, and just do each unit, you know, go by ones, all right? And that's fine. However, the graph I give you, you'll see it. You can just draw it, okay? And do it that way, all right? Now, I want to talk about this one because this is the square root function, okay? So what do we notice? Some things. Well, first of all, we don't notice any horizontal tangents, right? There's no horizontal tangents, okay? What that means, and if you look from here to here, okay, and I should say this, what that means is it's never going to cross the x-axis, all right? There's no way that this graph can cross the x-axis because it's never going to have a slope of 0, so that means the derivative is never going to be 0, all right? And if you look at all these, the derivative always has to be positive. These will all have tangent slopes. Now, right over here, it gets really super duper steep, right? So if you try to, like, you know, move a point along here, right, it's going to get steeper and steeper and steeper and steeper and steeper and really curve in here, right? and it's going to curve. And as we come down, it's going to go vertical. Okay, but can you have a vertical line? No, you can't, right? So what has to happen here is the slope is going to, and right before it, it's infinity, okay? So what's happening here is the slope is going to go to infinity as you approach this value, and all of the slopes have to be positive. So actually, this has the derivative of the square root function has both a vertical asymptote and a horizontal asymptote. Okay, I'll explain it again, just so in case you didn't quite get my explanation of that. So here I'm going to draw my vertical asymptote. All right. And okay, so how do I know there's a vertical asymptote? Okay, it's because as you move in here, that we have what's, well, I would say we would have right here, instead of a horizontal tangent line, we have a vertical tangent line. And what that means is the slope is undefined. Okay, that's another way of explaining it. So we have a vertical tangent instead of a horizontal tangent. Which means f prime is undefined because the slope is undefined there. That's what's causing this vertical asymptote right here. As you as you get closer, excuse me, need some water. As you get closer and closer to x equals 0, all right, what's happening is, let me pause this real quick. Okay, I'm better now. All right, so as you get closer and closer to x being 0, the slopes are becoming steeper and steeper and steeper into where they're going to infinity. This slope right here is infinity or negative infinity. Just before we get to the vertical, just before that, it was a positive slope. So that's why I know it's going to positive infinity. So I know it's going to come right up here. My graph has to come up here along that vertical asymptote. All right, so they're really, really big right here, the slopes, but then they start to slow down, right? And the slopes aren't as steep over here, all right? And all of these slopes are positive, but they're never 0. So if they're never 0, that means they all have to be in this first quadrant. And if I come down, right, I would have to cross the x-axis. But that's not true. The slope is always going to be positive, which means as we go further and further out, the slope keeps approaching 0, okay? And getting closer and closer to being 0. But it never reaches it. So that's a horizontal asymptote. So these slopes right here next to x equals 0, just to the right of x equals 0, are really, really steep. That's why we have a high value up here. Over here, they're really, really low, but positive. That's why we're going to end up right over here. And we're just going to connect them. So it's going to look something like that. All right. Okay. So again, if use your graph paper just to make a grid, you know, -10 by 10 and -10 by 10, whichever one I give you, make it the same size. Okay. And once again, all of these on the left side are the function, like y equals f of x or y equals g of x. Okay, and the ones on the right are all derivatives. So this is going -2 pi to 2 pi and -4 to 4. So I would draw this on your grid and just draw the derivative of this. Okay, so now we see horizontal tangents again, right? So we see ones right here, right there, and also right here and right here. So what does that mean? That means you have slopes that are 0 there, right? Which means on this, it would be on the x-axis. So right here in between -pi and -2 pi, the slope is going to be 0. So that's going to be right here. And then right here between 0 and -pi, we should be 0 again. And then between 0 and pi here, 0 again. And between pi and 2 pi right here, 0 again. Okay, so what do I know about this part right here? Well, those are all positive slopes, right? This function's increasing, which would mean the slopes all have to be positive. So right from here to here, all the slopes have to be positive, which means f prime has to be above the x-axis. So it's going to have to be above right here. And then from here to here, between these 2 points, all of my slopes are going to be negative because I know that this is decreasing, right? It's going down, which means the slopes all have to be negative. All right. And so it's going to look, you know, something like this. It's going to come down and then turn right here probably, and then come back up. All right. And then from this value to this value, I know all my slopes are positive. So it's going to have to turn and come this way and come back down to get through that point. All of these slopes are going to be negative. Okay. So, but I got to go from here to here and they all have to be negative. So the whole part has to be below. So it's going to look something like this. Okay. And then from here to here, they're going to be positive. So it's going to look something like, you know, something like that. All right. Now, if we had been in school during last spring, we probably would recognize these better. And some of you may recognize them from graphs that you've seen before. What is this the graph of? And you should be thinking this is the graph of y equals sine of x. So this function is the sine function. This one should look familiar too. Maybe maybe a little more curvy, maybe more, you know, like that. Okay. And this one probably should be a little more curvy too, like that. Okay. But it's starting at 1, right? And it kind of looks like this one, but it starts at 1. This one is the graph of y equals cosine x. What does this mean? So it's the first go around that you're going to see this. What this means is the derivative of sine x, this trig function, turns out to be cosine x. And that's actually going to be true. And I'm going to prove it to you later on. Okay. But yeah, the derivative of sine x is cosine x. Okay. All right. So that's that. All right. So you're looking for horizontal tangents. You're looking for vertical tangents. And then you're looking for where the tangent slopes are positive and where the tangent slopes are negative. And that's how you graph these, okay? Unless you have straight lines, then you can actually get the derivative, okay? Because whatever the slope of that straight line is, the derivative would be that slope, okay? Like we did on the very first problem. All right, guys, that's it.